Hey, Dr. McNamara here at McLaughlin Care, and I'm coming at you with another Wellness Wednesday. Now, today we're going to talk a little bit about energy systems that we use during running. This relates to, the macronutrients we put in our bodies, such as carbs, fats, proteins, and how we utilize those when we're performing certain activities. And what's really interesting about these energy systems is that you're going to notice each has a very specific role for very specific types of exercises and activities. So without further ado, let me share my screen and we can get started. So here we go. All right. So running metabolism, where is this energy coming from? And to start this conversation, we want to understand where energy does come from, and what it comes from is ATP, and that stands for adenosine triphosphate. And that is what you can think of it as our energy currency for our body. So similar to working for a job, making money, and then putting it into the bank for storage for later. Our bodies does this with ATP when we're resting and digesting, when we're eating food and we're resting and sleeping. We're building up these energy stores for later use. So you can think of the rest and digest portion as uh, the putting the money into the bank. And then when we actually perform the exercise, that's when we're withdrawing and we're spending that money. Okay. So the three main systems that we're going to talk about, and it is the ATP phosphocreatine system, the glycolytic system, and the oxidative system. Now, the ATP phosphocreatine system, those are high intensity type of activities that are in short duration, things like sprints, like short sprints, 50 to 100 meters type of activities, as well as powerlifting and even throwing other and things like that. And then we got our glycolytic system. That's going to be a little bit longer, and it's going to be more moderate intensity for a little bit longer duration, but still pretty moderate to high intensity. And this is for about 10 seconds to up to 2 minutes. And with these two pathways, the ATP phosphocreatine as well as the glycolytic, these do not require oxygen to do. So we do not need, we can, as soon as we begin the exercise, we're starting out with these systems. These are the first to go to before we build up any type of oxygen debt. When we do start to, build up that oxygen debt and we need to inhale more oxygen for our cells to create more energy, that's called oxidative phosphorylation, and that relies on our oxidative system. This is aerobic. This needs oxygen. This is the activities that are going to last longer than 2 to 3 minutes. They're a little bit lower in intensity, about moderate to low intensity, depending on your current level of fitness. So let's start with the ATP phosphocreatine system. Now, these are like our short sprints in terms of running, those 50 to 100 meter dashes. You can see on the left, I have the biochemistry of this pathway. If you want to learn more about that, you can look it up on at another time. That's a biochemistry lesson that we just don't have time for today. So when you're thinking of this system, this ATP phosphocreatine system, I want you to think strength and power. This is immediate energy, such as when you begin a workout, if you're powerlifting, if you're throwing something, sprinting, or short swimming as well. These are activities that last about 10 to 15 seconds. Um, Now with this, we need a substrate to produce this energy. And with this system, since it's our very first, we actually do rely on strictly ATP alone for about the first 5 to 6 seconds. Now muscles in our body, they actually have a little bit of stored ATP that they like to keep there just for any time in case, you fight or flight response, you got to run away from a bear in the forest or something like that from an evolutionary perspective. So we always had these little stores of ATP. After about 5 to 6 seconds, you were going to run out and we're going to need to rely on a different source. And that's where the creatine phosphate comes in. And that's going to supply energy for about another 5 to 10 seconds before those stores run out. And we have to switch to the glycolytic pathway. Now, what we can do is we can improve this system so we actually can extend out those high intense activities a little bit longer. And we can do that through our training. To improve this system, what you want to do is you want to do about 10 to 15 seconds of maximum intensity work, followed by about 2 to 3 minutes of rest. This is very important. We want to do full, all out intensity in order to deplete these stores completely. Then we want to wait the full 2 to 3 minutes so we can rebuild those stores so we can do it again, making this system more efficient. Very important to make sure you are fully recovered. We don't want to be huffing and puffing before we start the next repetition of these, okay? So the example workout for this type of training would be 50 to 100-meter sprints, intervals with about 2 to 3 rests in between. Again, make sure we are fully recovered before beginning the next one, because if we are not, we'll start moving into the glycolytic system. Now, the glycolytic system, these are like our longer duration sprints. This is up from the 200 to 400-meter dashes, even a little bit into the 800 for majority of the race. So again, I got the biochemistry on the left if you want to look closer into that. But when you're thinking about this system, again, I want you mostly thinking strength and power. This is going to be intense exercise or activity lasting anywhere from 10 seconds to about 2 minutes. That's about 2 minutes is where we start to build up too much hydrogen and lactate that we need oxygen to actually start to reduce some of those levels in our body and to produce more energy. Because once we get to a certain level, we can no longer produce as much energy through that process. Another thing with this buildup of the lactate and hydrogen ion, it used to be very popular belief that that soreness that we get after running is due to that buildup of lactate or lactic acid. That's not actually true. It's actually the increase of the hydrogen ion that's going to actually lower our pH, making our bodies more acidic, which those are going to cause those types of soreness and things like that. So the substrate for this pathway is in the name. So you see glycolytic, you can think glucose. So think sugar. This is what's breaking down sugar immediately. It's breaking down the glucose within our blood that's just freely within our bloodstream, as well as breaking down the glycogen, which is our stored form of glucose that we hold in our muscles as well as our liver. So as those break down, we produce energy. It's important to keep in mind that with this system, you have a certain amount of glycogen stores that you can fill. And once you fill those glycogen stores up completely, the rest of the sugar and carbohydrates that we are taking into our bodies is then going to be converted to fat for longer term storage. Because what our body wants to do is it wants to be as efficient as possible. And due to these restrictions on the amount of glycogen we can hold in our muscles, we have the process of lipogenesis, which is the conversion of sugars to fat that will occur if we are overfilling these stores. But what's great about these is we can actually improve our stores by training. And the way we do this is you're going to do repeated intervals of high intensity activities for about 30 to 60 seconds duration. And then you're going to follow that up with a shorter rest period of 1 to 2 minutes. Now, different from the PCR or the phosphocreatine ATP pathway, this we don't want to do full recovery. We want to build up a little bit of that oxygen debt and build up a little bit of that lactic acid threshold in order to improve the efficiency of this system. So these are very, very tough workouts. Think circuit training if you're lifting weights, as well as the longer sprint duration HIIT type of workouts. These are going to leave you winded, they're going to exhaust you, and you're going to want to make sure you do refuel with some carbohydrates after performing these types of exercises. Once we start to enter into longer duration or lower intensity type of exercise, that's when we start to really require oxygen for the long-term energy creation. And this is where we go into the oxidative system. And in terms of running, this is more of our long distance running, anything above about 800 meters to a marathon, even ultra marathons. We're going to be relying a lot on this oxidative system. Again, on the left, biochemistry. But when you think of this system, I want you to think more of efficiency and long duration type of exercise. So this is going to this system is going to be utilized for moderate to high intensity exercise lasting over 2 minutes, as well as low intensity exercise such as walking for a however long period of time. The substrate for this is going to be all macronutrients. We can use carbs, fats, and protein for this system. It utilizes the Krebs cycle, also known as the citric acid cycle or TCA cycle, if you've ever heard of that for you biochemistry aficionados, as well as the electron transport chain. So you guys can research that a little bit more if you want more information on that. And this is a oxygen dependent process. Another interesting thing is it actually prefers fat usually for this process, because fat is very easily broken down into pyruvate, which is then going to enter the citric acid cycle, Krebs cycle, whatever you want to call it. Um, so yeah, think of this as our really long-term type of energy. It's also just the energy systems we're mostly using as we're just sitting, throughout the day, going on walks. What's interesting about walking is you're actually going to burn a higher percentage of fat relative to the percentage of carbs you're burning at the time. Now, since it's lower intensity, we're not going to burn as many calories, so you have to put that into effect too, but it does burn a higher percentage of actual fat. So how do we improve this system? How do we improve this system so we can run longer at faster paces? In case you're interested in that kind of thing, maybe you have a marathon on the bucket list. This is the system we're really going to want to focus on. So to train it, we're going to do long duration, low intensity exercise lasting over 30 to 60 minutes. Now, there's a few ways we can do it. We can just do it, just a normal jog at a steady pace, or what we could do instead is do long intervals. It's best if we actually alternate the two, if your goal is to run long distance for time. So for the long intervals, what you want to do is you want to go for a ratio of about 1-to-1 or 1-to-2, meaning though we're going to rest either the same amount of time that we worked, or we're going to rest double the amount of time that we worked. So just a quick example of what we could do is moderate intensity running for about a minute. You can do it to 2 minutes, 3 minutes, depending on your goal, what race you want to perform. And then you're going to follow that for the same amount of time or double the time. And then we're going to repeat it about 5 times. So let's say our goal is to improve our mile time. Let's say we're running about a 6-7 minute mile and we want to improve this system. A great way to incorporate this type of training is to do the long intervals and do it to where we run for about 5 minutes. We'll run a little bit faster than we normally would because it's a little bit shorter than our normal 7-minute mile, because we're only running 5, so we'll run a little bit faster, and then we're going to rest, and then we're going to repeat that. And that's going to train that system so we can perform at a higher intensity for a longer period of time. So that is the oxidative system. These are the 3 systems of our body that we use for energy when we are exercising. If you have any questions or want more information, please leave a comment. And if you know anybody, if you're not following us already on Facebook, please check out our Facebook page, Upside of Wellness. We will be providing more information on there in regards to running as well as other health-related topics. But until then, keep exercising, keep running. I hope you guys learned something today, and I will see you next week.